Hey, this is Mr. Hansen. We're going to look at the Triangle Sum Theorem today. This is something you've seen in 7th or 8th grade. Simply stated, if you have a triangle, angle A plus angle B plus angle C, those three interior angles, I'll put a dot by each one. Each of those three angles put together, added up, equals 180 degrees. So the question might be, how do we know it equals 180 degrees? In the past, you have maybe you did a little experiment where you tore off the edge of this triangle, and you tore off the edge here, and you tore off the edge there, and then you lined them up, and they look something like this: 1, 2, 3 edges, and they kind of formed a line, and you knew a line was 180 degrees, and that's an okay explanation. Except that the question probably arises, would this work for every case? And then you would have to think to yourself, how many triangles would I have to tear off the edges of and do this experiment with to determine that it works for every case? Well, it would be an infinite number of triangles. So there's a little bit of a situational problem with this type of reasoning, and that is that you have to come up with an infinite number of examples of how it works. Otherwise, there might be one counterexample that it does not work, and then you can't say that this is a true statement. So we're going to look at a couple of other ways to consider proving that there are 180 degrees in a triangle. So here's a triangle. We'll call this angle A and angle B and angle C. We want to prove that there's 180 degrees there. Well, when you're starting to think about proofs, you have to start thinking about things that you already know that can help you to discover new things. This is kind of the way that a proof works. And so what have we been studying recently that might help us? If you think back to the last chapter, we talked a little bit about parallel lines. So I'm going to draw a line parallel to the base, put a little triangle there and a triangle there, a line parallel to that base, and I'm going to extend, actually don't need to extend that. Okay, so there's a pair of parallel lines, and let's go and fill in. Let's call this angle D here and this angle E there. Now take just a moment and think about how you might prove that A plus B plus C equals 180. You might use angle D and angle E and something that you know about parallel lines to make this happen. I'm going to give you a minute to think about it. Hopefully you've taken the time to stop this and pause this video and think about it. So let's set up a little bit of a proof. And the nice thing about putting in letters instead of numbers here is this means that it would occur for any case. So it's very general, not specific, and that's why we use variables here. It expands the power of what we're trying to prove. So here's statement and reason. First of all, I'm going to do it over here so we have plenty of room. Statement and reason. First of all, let's think about what we know about angle D and A and E. You can see that they form a line. So these three angles add up to 180 degrees. It's probably a little bit, I'm just going to write linear pair here. It's more like a linear triple, but when you have two angles that form a line, it adds up to 180. If you have three angles that form a line, those three angles add up to 182. So D plus A plus E equals 180 degrees. Now what do we know about D and B? D is congruent to angle B because they are alternate interior angles. Hopefully you can see beyond just this triangle. Hopefully you're seeing the parallel lines and I'm going to just extend this so you can kind of see the transversal here. So D and B are congruent. They're alternate interior angles. E and C, same thing. And the reason? Same reason. Alternate interior angles. All right, and here's an interesting one. Angle A. Angle A is congruent to itself. And the property, when something is congruent to itself, we call it reflexive property. Why would that be important to know that it's congruent to itself? We're going to use angle A as part of the linear pair, but also we're going to use it as part of the triangle. So when we use it as a linear pair or whether we use it as a triangle, it's going to have the same value. The two angles are congruent. Okay, let's see what we can do here. Looking at the top one, we've got D plus A plus E equals 180. Well, in place of D, what could we put in place of D? Look at the second one. We can put B. So I'm going to put angle B. And in place of A, well, A is equal to itself, so I'm going to put angle A. And then in place of angle C, right here, we've got in place of angle E, we've got angle C there. So angle B plus angle A plus angle C equals 180. And the reason is substitution. We have substituted some values in to make that work. So we wanted to prove angle A plus angle B plus angle C is 180. We have angle B plus angle A plus angle C is 180. We could take one last step and rearrange these two angles here using the commutative property. And there you have it. That is a proof. Much more powerful than just coming up with a whole bunch of examples of how it works. This is telling you that it will work every time and you don't have to worry about it not working. Okay, I wanted to take a look at this same idea with you. But this time take a little different approach. So I've got A here, and let's do A, B, C again. A, B, C, and we'll call this one D here. Okay, if you remembered something about external angles theorem, that said something like this. If you have this angle outside, these two remote interior angles are the same thing added up to that angle there. So let's take a look here and see if we can prove the triangle sum theorem using this idea of exterior angles theorem. So first of all, what do we know about D and A? Angle D is congruent to angle A, and the reason why is they are a linear pair. And let's put angle A is congruent to angle A again. And the reason for that is the reflexive property, so we're just using it two different ways. And then angle D is congruent to angle B plus C. And that is your exterior angles theorem. Exterior angle theorem. Okay, so now we just need to say that we need to replace B and C with the, oh boy, I made a big mistake up here. D and A aren't congruent, they're supplementary. Angle D plus angle A equals 180 degrees. They're a linear pair, so they're supplementary. Okay, so now we need to take a look at B and C. And since D is equal to B plus C, let's just exchange for angle D up here. We're going to put B plus C up there. So angle B plus angle C plus angle A equals 180. And that's substitution again. And you can switch it around a little bit and say angle A plus angle B plus angle C equals 180. And there you have it. So yet another way to show or prove that there will always be 180 degrees in the three interior angles of a triangle. Let's take a look at one more. Here we have a triangle. And I'm going to put 2 there and 3 there so we know they're different. And we have a similar triangle. Like that. And we just keep shrinking it down to size. And I want you to think about maybe extending, as you shrink this, kind of think about extending some spindles here, these exterior angles like that. And think about what happens as you shrink this down to a single point. What's going to happen with those 3 angles there? So the triangle just keeps getting smaller and smaller and smaller. And eventually at that point it's going to look something like this. So you've got this line going this way, and a line going that way, and a line going that way, and a line going that way. And they end up equaling 180 degrees. This isn't the easiest to see. Without a lot of computer animation, but that's kind of how that works. If you shrink a triangle down to a point, you can see that these angles end up being 180 degrees. So that's using dilation. This one was using the exterior angles theorem, and this one was using the parallel lines and the alternate interior angles theorem. There are probably lots of other ways to prove that triangle A plus B plus C equals 180. The big idea is that we want to prove it for every case, not just use examples, and that's a way of thinking called deductive logic, and it helps us know for certain that triangle A plus angle A plus angle B plus angle C equals 180 degrees.